All right, this is our heat exchanger equations and application once again. So I know that this is probably the fourth time we've already talked about this, but the three equations rather, that we have to know and understand how to use are located on this page. This first one, we can see I have that the rate of heat transfer is equal to mass flow rate times the specific heat capacity of the fluid, and then the differential temperature once again. Remember what the rule was. Note, no phase change is allowed when using this equation. All right? The other equation you see on there, the rate of heat transfer is equal to mass flow rate times change in enthalpy. I can use this anytime if I can determine the change in enthalpy that's occurring. And then finally in the upper right here, you'll see the rate of heat transfer is also equal to U, which we'll go over in heat transfer and fluid flow really well, but this is the overall heat transfer coefficient, times area, times the differential temperature once again. And very important, you see that that differential temperature is the average temperature of the hot minus the average temperature of the cold. So we're going to be able to have to use these. It says basic heat transfer and heat exchanger. We're going to solve using these three equations right here. All right? Recognize that there are limitations to this one. No phase change allowed in this one right here. No phase change allowed to use that equation. All right? Don't use it if there's a phase change, i.e. the shell side of the condenser. And also, we're going to have to get good at using steam tables. Now, we're going to go over these a lot in thermodynamics, but we're going to have to learn how to use these, especially when it comes to finding this change in enthalpy right here, change in enthalpy. So we'll be looking at that in more detail.